All right, IB, it's Miss Kosh, and this is one of my favorite things to teach. This is called proof by induction. And when we start talking about this, I like to compare it to a ladder. This is my attempt to draw a ladder. There's a reason I don't teach you art. Okay, so in order to climb the ladder, we first have to be able to get our foot on the ladder. If you can't even get your foot on the first step, then you can't climb the whole ladder. You're out. You've lost the game already at that point. And then we're going to assume that we're at some random step and then prove that we can make it to the step after. Okay, and I'll show you how this fits in mathematically in just a second, but that's the idea. If you can get on the ladder, that's step one. If you can assume, then step two would be that you assume that you're at some random step anywhere on the ladder. If you can go from that one to the one after it, then you can climb the whole ladder. Okay, so what we're going to say, this one is we're going to let n equal 1 here, and then this becomes n equals k with some random letter or some random step on the ladder, and then the one that came right after that is obviously n equals k plus 1. Okay, so let's do that. This is a series problem, and this is the first type of induction proof that we are going to do. And so they want us to prove by induction that the sum as I goes from 1 to n of I is equal to n times n plus 1 over 2. This, I just pulled up the previous notes that we had done. This is off of that chart, and we had kind of generated this formula, but now we're going to prove it in a different way. Okay, so we're going to prove with induction. So to begin with, step one, you might say show or prove n equals 1. Okay, so what we'll do is we'll say some of these, then you could say, okay, the left-hand side is the sum as I goes from 1 to 1 of I. Well, this is just equal to 1, and that's the left-hand side. Then we could do the right-hand side is equal to 1 over 1 plus 1, not over, 1 times 1 plus 1 over 2. This is equal to 1 times 2 over 2. The 2's cancel, and that equals 1. Okay, and we have now shown that the left-hand side and the right-hand side match. Step 2 says assume n equals k is true. Okay, so we're going to assume now that the sum as I goes from 1 to k of I, we're going to assume that that's equal to k times k plus 1 over 2. You'll notice all I did is I came up to this up here and rewrote all my n's as k's. Okay, yep, there we go. So that's all of step 2. So sometimes step 1 gets interesting depending on the problem, and step 3 is always the most interesting. Step 2 is it's extremely essential, but like if I were going to divide up, if this were a 10-point problem, I would make this be worth 2 and this worth 1, and then the part 3 would be worth 7. I mean, it's that kind of a level of split. Okay, anyway, that's neither here nor there. All right, so now step 3 says show n equals k plus 1. So show that that is true. So with this one, what I often find to be helpful is I often come back and I like to write down the goal. And so the goal in this problem is to say that, okay, the sum as I goes from 1 to what? Well, now we're going to k plus 1 of I. That needs to equal k plus 1 times k plus 1 plus 1 over 2. Okay, notice what I did is I substituted those n's over here in this equation for k plus 1. And it's definitely very helpful. Oop, I erased the wrong thing. Oh well. Okay, hang on. That's going to bother me. I'm sorry. N times n plus 1. Okay. This goal is going to help us know when did we get where we need to get. Okay, have we made it? So this you'll notice is k plus 1 times k plus 2 over 2, or you might even, that might be enough to let us know that we've arrived, or maybe we should FOIL it out. K squared plus 3k plus 2 over 2. If we see that, then we know we're there. Okay, so that's the goal. Now we're just going to get started here. So we're going to say, okay, the sum as I goes from 1 to k plus 1 of I, well, this is equal to the sum as I goes from 1 to k of I plus the next term. Okay, so if you think about it with a sequence, so if I have the first term plus the second term plus the third term plus dot dot dot, I get to the nth term, or you know what, I don't want to say n, I want to say the kth term. The term that came right after that is a sub k plus 1, right? The k plus 1th term. Well, all of this right here would be the sum of k terms. Okay, or we might say the sum as I goes from 1 to k of whatever the mess is. Okay, and so then it's all of that plus the very next term, it's the k plus 1th term. Okay, that's what's happening in this problem. So looking back over here, the k plus 1th term means that I come to this and I plug in, or maybe I didn't need to highlight that one, I can come to this, same idea, and plug in k plus 1. If I plug in k plus 1, my I just becomes k plus 1. Okay? So now I need to turn this mess right here into my goal. So somehow I have to manipulate my step 3 so that I get down to the goal. This, by the way, is scratch work. So I was just helping you understand what was happening. And really and truly, the green is scratch work also. But it's very helpful and you can put it off to the side. Okay, so what do we know? Well, we just assumed what we know to be true about as I goes from 1 to k of I. We know that this is equal to k times k plus 1 over 2. And plus now we're adding a k plus 1. Okay, so what's my goal? K plus 1 times k plus 2 over 2. Well, so I can't add those together until I get a common denominator. So let's think of this as being k plus 1 over 1. And so therefore what I need to multiply by is I need to multiply by 2 over 2. And so this gives me now k times k plus 1 plus 2 times k plus 1 all over 2. Okay, and now if you remember from before, do you remember in the last video, there's a reason I left this here. Remember back here where I factored out the n and then I factored out the n plus 1 and I said that's going to be helpful with induction? I didn't lie to you. I mean, I might sometimes, but I didn't then. I don't tend to lie on purpose. But notice, here's my point, notice that I can factor out a k plus 1. And what I'm left with is a k plus 2 all over 2. And I want you to get to this top, we need to see this top statement, okay, where all of my n's have been substituted in for, k plus 1 has been substituted into all of my n's. And so now we can say, okay, well this is k plus 1 times k plus 1 plus 1 all over 2. And then we always conclude, we always use the 3 little dots to say therefore. Therefore, the sum as I goes from 1 to n of I is equal to n times n plus 1 over 2. And that, we restate what we were trying to prove at the very beginning. Okay, and that one's pretty straightforward. They definitely get more involved. I feel like doing another one, so I'm going to make a second video just to do let's see, I'm deciding. Let's do, I'll do this one in the next video. So come watch that, and then it's time to practice. And then you've got to jump in and work problem after problem after problem. You can also, do you remember, I talked about how your homework assignment was to create, from before, was to create, to take this situation and figure out what it was going to be equivalent to down here. That is now this. You could now say, you could now make that one of your proofs. Prove as I goes from 1 to n of I squared minus 6i, prove that equals n times n plus 1 times 2n minus 17 all over 6. This is now something you could prove by induction. Maybe that's what I should prove. No, I'll do the squared one in the next video. All right, go practice. Watch the second video if you're interested, and then practice, practice, practice. It's one thing for it to make sense when Ms. Kosh does it. It's something else entirely different for you to be able to do it on your own. So you have to practice. Goodbye. Good luck.